Right, let us come back and see this 2016 paper. So in 2016 paper, I think we've started with this identifying A, B and C compounds and conversions. Let us see this. What do they give us? They've given us acyl chloride and they've given me hydrogen and palladium and barium sulfate. So palladium and barium sulfate we've already seen in Rosenman reduction. That is what we've used palladium for as a reducing agent. So simple. They've already given me hydrogen. I have to add this hydrogen to this. How is this hydrogen? It is like this basically. What should you do? You have to take out HCl and add this hydrogen. Basically the reaction is like this. COCl plus H and H. So I'm taking out hydrogen. So what do I get? I'm going to get CH3CHO, aldehyde. I've got that. Simple. So write this compound. This is your A product. Done. Then what did we do? We have added hydroxylamine to this reaction. When you're adding hydroxylamine, your only task is to remove your water. Yes, so here you have to be very careful. Your hydroxyl or aldehyde, it is basically like this, isn't it? Your double bond O and H. This is important. So you should not, why am I writing this? Because more you forget about the double bond. You have to be very careful with that double bond. So what product do you get? You get CH3, your CH, correct? And your double bond NOH. This is your B part. Simple. Now this is your acetaldehyde and this is your hydroxylamine. So this is called oxime. Hydroxylamine and oxime. That's it. Now let us solve the next one. So in next reaction they've given me Grignard reagent. This reaction also I have done. Addition of Grignard reagent with carbon dioxide. How should you do this reaction? CH3, this is like this, MgBr. Now your carbon dioxide when I take, this is your carbon dioxide. Now due to the electronegativity difference, this shifts here. Yes, and this becomes minus and this becomes plus. There's a cleavage of the bond. Yes, so when there's a cleavage of the bond, now observe, this becomes plus. Yes, this becomes minus. Your O comes and attacks your methyl group. And when I further hydrolyze, okay, I'll show that also. So first important thing, what should I write? I have to write CH3, your C, your whole carbon dioxide comes and adds to this with minus charge, plus your MgBr. Okay, now and this when I further hydrolyze. Now what is this compound? Still I'm not done. I'm going to further hydrolyze this compound, H plus no OH. This is in presence of water. Then what do you get? You get an H, right? This water molecule is divided like this, isn't it? H and OH. Your H plus goes and attacks your oxygen and your OH comes and attacks this bromine. What do you get? You get CH3COOH plus MgOHBr. This is your compound. So write that. We've already got A part now. Your A part is CH3COOH. So your carbon dioxide converts Grignard reagent into acetic acid. Now this is your reaction. Now let me use that the second part. Now I have already got acetic acid. I have to add PCl5. We already did this, CH3COOH plus PCl5. I said first compound PCl5 forms is acyl chloride. I already did that day. It is PCl5 like this. PCl5, 3, 4, 5. Yes. So CH3COCl, first compound. CH3COCl, the leftover. You get how many did we take for PCl3? 3 moles. For PCl5, just it is a formation of POCl3. PO, yes, yeah, this is CH3COCl, no? So this is your oxygen. Now observe, it is your POCl3. We get POCl3, 3 plus 1, 4, and the leftover HCl. HCl. This is your product. They don't want you to write all. They want you to just write. This is your B part. CH3COCl. This is your B. That's it. Reaction is done. So let us erase this. I have to do this question. Distinguish between C6. This is your benzo. Which phenol is this? Acetophenone. C6H5COCH3 is acetophenone, and this is benzaldehyde. I have to write the distinguishing test. So I'll erase this part of the board and let us write that particular thing. So when such question is given to you, you can just write. First, copy the compound. As I say every time, C6H5COCH3. Next compound is benzaldehyde, C6H5CHO, right? Now, this is your acetophenone or this is your methyl ketone, correct? So this is your methyl ketone group. So methyl ketone. This is your aldehyde. Now we very well know methyl ketones show which test? They show iodoform test. You can write shows iodoform test when treated with iodine in the presence of NaOH to form an yellow PPT of iodoform. This doesn't show no reaction. So you can write no reaction. Why? Because of the absence of methyl ketone. Because of the absence of methyl ketone. That's it. You're done. So let us do the last one, second one. They've given me to compare between acetic acid and formic acid. Okay. Right, so let us come back and solve this question. So what is this? What do they say? They want us to distinguish between acetic acid and formic acid. So again, pick up formic acid here on one side and your acetic acid on both sides, right? So what are you going to write? Suppose if you forget the particular reaction, right? Suppose you forget your Tollens reagent reaction or your iodoform reaction or Felling's solution A and B, that a Felling's test, then you can directly write what are you using for the test and finally write the product form, right? So what do? You can just write when Tollens reagent. What is Tollens reagent? Basically, we have also already seen ammoniacal silver nitrate is Tollens reagent. So write that here. Ammoniacal silver nitrate, yeah, is added to formic acid. Right. What is the test we get for ammoniacal silver nitrate? Silver mirror, isn't it? You get a silver mirror on the walls of the test tube. So just write silver mirror was observed on the walls on the walls of the test tube. Yes, of the test tube. So this gives positive Tollens reagent test. But here you can write no reaction with Tollens test, with Tollens reagent. That's it. This is how you're going to write. So write this test if you don't remember the reaction and finish off your answer. So we are done with this. Let us do the last one. So what do they give us? Arrange the following in the increasing order of the boiling point. I have to write the answer in the increasing order. That means the one which has the maximum boiling point should be written at the end and the one which has the minimum should be written at the starting. So let us erase this and write the last one. Complete the part A of 2016. So you have to write. So how should you write the heading? Increasing, right? So write like that. Increasing order of boiling point. So write like this. So when you write like this, the examiner clearly knows that you are arranging in the increasing order. Most of the students write it in the reverse order. They write the maximum one at the first and the minimum one at the last. Now when I have to arrange, this is your acetaldehyde, this is your acetic acid, this is your ethanol. So what do we know? Acetic acid, whenever you have boiling point concept, you have to stress more on hydrogen bonding formation. So higher the hydrogen bonding, more would be the boiling point. So just see here in acetic acid, you have two sites of boiling point, two sites of hydrogen bonding. So the maximum would be acetic acid. Then let us come back. When I compare acetaldehyde and this, here you have one site, yeah. One side from here and here hydrogen bonding, it can join from oxygen to hydrogen of the next atom. So your second would be ethanol and the leftover is aldehyde. So just see how did I write? Minimum boiling point a bit higher than that, the maximum boiling point based on hydrogen bonding.